So today I'll be talking about calendar algorithm. So that is nothing but the idea of the relationship between day, month, and year. So before talking about calendar algorithm, first I'd like to tell you about this history, that how does this work and how does actually our calendar works. So actually we know that our Earth takes around at 365 days, 5 hours, 48 minutes, 46 seconds, which is, if we convert it into decimal, which is nothing but 365.2422 days, which is almost equivalent to 365.25, nothing but 365 and 1.5. So that's why this idea came. After each 4 years, we add 1 day to make this gap. So make this just reduce. So just remove this gap. So it was introduced by the King Julius Caesar. So that's how the Julian calendar was introduced. But this has a little problem because it was lacking behind each 120 years. Like after each 120 years, it was lacking 1 day. Like each 128 years, it was lacking 1 day. So when it happened, when 1582, at the year of 1522, when vernal equinox, it is nothing but the day where the date where the length of day and length of night is equal. The vernal equinox, the date usually falls onto 11th of March. In the usual calendar, in that time it fell on 21st of March. So as it was, 1 day, it was going to like 1 day short, like each 128 years. So it fell down about 10 days short. So that's why it for thoda piche chala gaya. It just came after like 10 days. So the 11 words, the vernal equinox, it was happened on 21st of March. So to rectify this error, what Pope Gregory the 13th did at that time, what Pope Gregory the 13th did, in October, after 4th October, after that, the 5th, 6th, it was just vanished. I mean, he dismantled those dates. After 4th October, it came to 15th of October. So he removed those 10 days from the calendar, and he made a decree, and all the Europes, except all those Catholic countries that followed them. So in October the 4th, after October 4th, it was October 15th. So those 10 days are, and that's how it works. And also he made it happen in this way, like for every 4-year gap, if it is a centurion, if the year is a century, like 2100, if it is not divisible by 400, if it is not divisible by 400, then it will not be a leap year. So it was invented. This idea was invented by a German mathematician, Christopher Clavius. He said this idea to rectify this error. Like, how does it work? There's nothing but each 4-year will be a leap year. We'll add a day, but those which is not divisible by 400, those centurion, actually, not those centurions, which is not divisible by 400, which will there will not be a leap year. Okay, so that's how this idea was introduced. And after 1582, all America and China and all those other countries, they started following this idea. So now the calendar that we use, which is nothing but the Gregorian calendar. Okay, so let me go to this first. So what I'll be discussing today, that how to predict the date in the future. Like today is the Monday, like 16th of December 2021. What will the date of 16th of December 2022? What will the date of 16th of December 2095? The idea comes along with this. Now we know the 6th of December 2021 is Monday. Then you always know that after 7 days gap, that means the 13th, the 13th of December, it will also be a Monday. So that's how we are going to compute. So idea is the idea. So let me start with this saying that let's consider this, that the Sundays, Mondays, let's give this some digit, understand with the digit. Tuesday, Wednesday, Thursday, Friday, and Saturday. Let's give them some numbers like it is 0, 1, 2, 3, 4, 5, 6. Okay. And also for each calendar year, Y, consider in this way. A March, give this month the number 1. April, give this month a number 2. And that's how followed by December, it will be nothing but number 10. And then January, it will be 11. And February, it will be 12. So it is, so how, so it is nothing but like this, each for like each 365 days in leap year, we add this 1 day at February, right? So considering this way, the year starts at March and ends at February. And after each February, in the case of leap year, we add the extra date at the end of February. So if it is 2010, in our system, March is the number of, with the March is 1. So that means this February, for 2010, this February is 12, but this February is not actually 2012 10th February. This actually in reality it is the 2011 February. Okay, just make this clear. Okay. So how will you do it? Let me take this thing. Now we all know this, like A is congruent to B. A is congruent modulo N to B. So that means A minus B is divisible by A. Let's give it some example. Like it's 7 and 17. You can write it this way. Because 10 divides 7 minus 7. Right? Like 10 divides minus 10, yes. That is nothing but if we write in this way, A is congruent modulo, A and B are related just that way, that A is congruent modulo N to B. That means A minus B is divisible by N. So like this, if we introduce in this way, that let's say in our calendar, it's 6 is the Monday. And we know that the next 13 will be our next Monday. So as we can write it down this way, the 6, 13 and 6 are congruent modulo 7. Because 13 minus 6 is always 7. 6 minus 6 is always 7 and it is also divisible by 7. So 13 and 6 are congruent modulo 7. Similarly, 6, 13 as well as 20. So 13 and 20 are also congruent modulo 7. Like in this way, like in calendar, let's talk about Monday. Like is 20 and 6 will also be congruent modulo 7, right? These are all congruent modulo 7. So what happens is, consider this Monday as 0. Sorry, Monday as 1, Sunday as 0. So all we can find out is this way. If we know the 6th of this month is Monday, we can easily find out that This 13th of this month is always a Monday. Similarly, it's 14. If it is 14, it will always be 12. If 13 is Monday, 14 will be Thursday. If 20 is a Monday, then 21 is always be the Tuesday. That's how you're going to figure it out. Okay. So let's not waste any time and just go in next part, next section. Now, as we all know that 365 but 1 mod 7, because let me check it. Yes. So 365 is also 1 mod 7 because 365 minus 1 is 364 and 364 is divisible by 7, right? Because 364 divisible by 7, it's always 52. So 365 and 1 are congruent modulo 7. So now if we know, like, let's say for a year Y, if we know the first March, if we know the first March, like the day of the first March could be Sunday, Monday, Tuesday, Wednesday, it would be 0 to 6, any of the numbers. So if we know the number, I mean that the day we know, let's write it down as dy. Dy is nothing but the number, like 0 to 6. 0, dy is nothing but, it could be anything, 0, 1, 2, up to 6. It could be anything, 0 to 6. It could be anything, okay. So let's say the first March of this year Y, calendar year Y, is dy. That is, could be number 0 to 6. We know the date. So that for the year Y plus 1, the next year, the first March would be dy plus 1, right? Because no, if it is, it increases 1 day, right? 365 is 1 mod 7. That means dy plus 1, dy plus 1 means y plus 1 calendar year, the first March, that is dy plus 1 is congruent modulo dy plus 1. Dy plus 1 and dy plus 1, they are congruent modulo to 7. Let me tell you once again that if it is Monday, like 1, it will always be 2. That means it will be Tuesday. So that's what, if it is Wednesday, it will be, Thursday, where with Wednesday, Thursday. So it, like I said, it's Monday, it is Tuesday. That's what I'm talking. It is dy plus 1. So that similarly, if we increase this way, like the second year, if the dy plus 2, nothing but dy plus 2 mod 7. Now in this way, series. So if our starting year, let's say we are starting with 1600. We are starting from the year 1600. So let's say D1600 is the number. Let's say D1600 is the number, is the day that first month, this first day of, let's say day of first March of calendar year 1600. If it is, we establish the relationship, that is the 1601, that is first March of the 1601 is congruent modulo to 1600. So right. So what happened if it is 1605? Now we know that 1604 is a leap year. It is a leap year. That means D1605 which will be congruent modulo to D1600 plus 5 plus 1 day extra for that leap year. Right. Because let's say we know this 1600, it is, let's say 1. That means it was Monday. Then if it is Monday, then we know then 1601, it will be 2. That means Tuesday. Then that means the 1603, it will be 3. That means Wednesday. D1604, that means 1st March of calendar year 1604. That will be 4. Monday, Tuesday, Wednesday, Thursday. But what is will be the D1605? Because now 1604, it has 366 days. So it will increase 2 days, right? 4 plus 1. 4 plus 2, it will be 6. It will be Saturday. So that's what it was. So that's why it was D1600 plus 6. So let me tell you in this way. So if we write it, let's say we have a, this is starting year is 1600. Let's say that this is a starting year. Starting year. Let's say it is our starting year. So if it is our starting year, then and if we are finding this is our target year and we are finding dy. If it is a target year and we are finding dy, that means what will be the day of 1st March of this calendar year? This is nothing but this will be congruent modulo. Obviously, it will be congruent to 7, which is nothing but the year, the date, the number D1600 plus the gap between them, y minus 1600, and we add some value L, which is L is nothing but number of leap years. They even like for 1600, it was 1 leap year. 1605 because 1600 and 1605 in between there is a 1 leap year here. But it is if it is a y, then we have to find out how many leap years or number of leap years between 1600 and y, right? Okay. So the idea is very simple. We are talking about the 1st March of the calendar year y, starting from here, the dy, the number will be nothing but if we start from the 1600, it will from 1600 minus y plus L mod 7. If we started from 2020, the idea is similar. It will be the same. Now, let's the next step that we would like to make it simpler because let's say our y is 20. Let's say different century 2120. You are starting from 1600. It should be a huge number. The number of leap years counting. So we want to make it easy. So in this way. So let's now we know that how do we calculate that? What is L? L is number of leap years. So like I said, how do we calculate number of leap years? Because we have to find out how many years that are divisible by 4. How many years and also if it is century, we have to check it how many years there are. If it is divisible by 100 and divisible by 400, then it's a leap year. So now we know when you are going to check like how the years divisible by 4, that means we will be also checking including those years divisible by 100 and divisible by 400 as well. So you have to subtract those years, those number of years which are divisible by 400. Similar, so in this way we can write it down. Number of leap year nothing but number. Let's write it down in this way. Hash now number of years divisible by 4 . plus number of y years divisible by 400 minus number of years divisible by 100 as well. So if it is our starting year is, let's say in this case we are doing starting year is 1600. So that means how do we find it out? In this way, like y minus 1600 divisible by 4. Like let's say if we have 16, if our target year y is 16 or 10 and we're starting from 1600, so we know that there will be only 2 years, right? 1604 and 1608. 1610 minus 1600 by 4 is nothing but 10 by 4, which is around 2.5. But if we use the box function, it will give us the result that we're looking for. That's why using box function, the integer. That is number of that. This is y minus 1600 by 4. This is number of years divisible by 4 plus those years y minus 1600 divisible by 400 minus y minus 1600 divisible by 100. Okay. So it will be L is nothing but y by 4 minus 400 plus, it was y minus 1600 divided by 4. So this is nothing but y by 4 or 400. Next part will be we are dividing by 400. Y by 400 minus 4 minus y by, you can check it out what's there. It was a y by 4 by 400. It will be y by 400 by 4 minus 4 will be y by 100 minus 16. Y by 100 minus 16. Now we know how box function works, because box a minus a is nothing but, if say a is integer, it will be box a minus a always, nothing. In that case, we all know 400 these are integers. So y by 4 is nothing but y. Okay, y by 4, y by 400, y by 400 minus y by 100 will be remaining. These are number of leap years we are counting, and it will be left over as minus 388. These are the number of leap years. So by that, to that idea, dy is now a congruent modulo d1600 plus y minus 1600 plus y by 4 plus y by 400 minus box of y by 100 minus 388. This is modulo. This number is congruent modulo 7. So let me write it down freshly in a different color. dy, this is the first number, the day of the first month of the calendar year y, which is will be calculating with this 1600 plus y plus y by 4 plus y by 400 plus sorry, it will be minus y by 100, then it is nothing but minus 1600 minus 388, which is, let me write it down firstly, which is 1988. 1988, yes, it's nothing but 1988. To get the idea goes to boils down to this. Let's give it an example in this way. Like, how did you calculate? How do we calculate? This is how we calculate. Let's give it an example. Like, if we are trying to find out how many leap years are there. Okay, how many leap years are between the calendar year 1600 and 1995. That means how many leap years there, but how many L's? So L is nothing but what we have discovered, y by 4. That this is the one. This is the starting year, plus y by 400 minus y by 100 minus 388. That means 1995 by 4 box of this, 1995 by 400 minus 1995 by 100, 88, nothing but 498 plus 4 minus 19 minus 388, which is equals to 95. So in between there are 95 years, those were leap years. Now it's very easy that what will be our D 1995, which is equivalent to D 1600 plus 1995 minus 1600 plus those A, that is 95. Nothing but 1600 what does it make? It is nothing but 91995 plus 95 minus 1600 plus 490. This 490 mod 7, which is equivalent to D 1600. Sorry, D 1600 mod 7. Like it is, we have discussed now. So 3 and 10, 3 and 10 are congruent modulo 7, and 3 and 17 is also 3 and 17 also congruent modulo 7. That's what we have used, right? What is 17? It is nothing but some 10 plus 7. 3 and 10 is also congruent modulo 7, then 3 and 17 is also congruent modulo 7. That's what we have used. So D plus 1995, which is 7, then it is, we can say that D 1995 and D 1600, they are also congruent modulo 7. So what does this make? This makes that in 1995 and in 1600, the day of the first March both were the same. Like if it is Saturday, then it will also be Saturday. If the day of the first March, day of first 1995 first March, if it is Sunday, it was also Sunday. Now in our calendar, we can easily find it out that the first March of the calendar year 1995, it was Wednesday. That means, according to our consideration, the value is 3. That makes what? The D1600 is also 3. These are also same. These are all Wednesday. So this actually dynamically changes our formula as well. What does it change? Let me write it down. So now dy is nothing but, now D1600 is 3. We know that. So 3 plus y minus 1600 plus number of leap years. And we have calculated that 1600 in this way. We have calculated before that here we have calculated. Let me show. So here we have calculated dy is nothing. Here we have to just put in the value 3 here. The y plus y by 4, y by 400 by 1988. Let me write it down in this way. Okay, let me write it down. 1600 plus y minus 1600 plus y by 4 plus y by 400 minus y by 100 whole divided minus 388. These are the congruent modulo 7. That means we have calculated this is 1988, and it will be nothing but, let's write it down as well. Log y plus y by 4 plus y box of y 400 plus, sorry, it will be minus, you know what, let's write it down more fairly. Y plus y by 4 plus y by 400 minus y by 100. Yes, and this makes 1988 and minus plus 3. That will be 88, 85 minus 1985 is modulus, congruent modulus 7 dy. So this is our conclusion. Excellent. Okay. So now we came to know that what our dy. That means first March of the calendar year Y, the relationship between this, like always this, now we always establish the what will be, now the dy is nothing but, like we have said, that it will be y plus box of y plus 4. I'm writing it again, I don't know why, minus y by 100 minus 1985. Now we know that. If we know, now if our y is some like 2022, if we put down this, like what will be our dy? Then d22, which is nothing but first March of day of the first month of the calendar year 2022, which will be calculated in this way: 2022 minus 1985 plus 2022 by 4 plus 2022 by 400 minus 2022 by 100 small 7. That we have understood. Now let's I would like to make it more simpler. Now we know each every year we can write it down this way, like it is some composed of some 100c plus y, where y is nothing but the number between from 0 to 99. Let's insert for 2022. C is 20, it's 20, 21st, this is 20, and the y is 22. 2020. Right? In this case, C is nothing but 20 and y is 22. So the previous formula can be written as more simply verbal. Like each and every capital Y can be written in this way. It's composed of two parts: the century part and this year part. This part. So we can simplify more, writing in this way that dy is equivalent to, if we calculate more, like in this way, we can calculate. Let me check. What was the item? It was at first, it was y. So let me write in this way. Y means 100c plus y plus, it was y by 4. That means 100c plus y by 4. Then it was, yes, it was something like this. 100c plus y by 400. Then it was minus of 100c plus y by 100. Then what it was? It was this minus 1985. This was this thing. Now we have to calculate this part. The 100c remains same, and let's see what happens. So what is dy now? Hundred remains, and let's break it down. Here I can break it down as well. So what will happen? This part will give this. This is nothing but 25c plus y by 4. Okay. Now from y by 4, we will get some integer. What will this be? This is nothing but box of c by 4 c by 4 plus y by 400. Now, if our y is 0 to 99, y by 400 is always a fraction. So we can ignore this because it will always be nothing but c by 4. This is a fraction. So it will be always be equivalent to c by 4. Similarly, this part also always be only c. Right. So what will happen then we can write it down in this way, that the 100c plus y is fixed. Nothing but 100c plus y. This seems to be fixed, but they are the remaining. Here we get 25c. This is also an integer. 25c plus y by 4. We'll get it this way. Plus 25c plus box of y by 4 right, then what will you get? Here we are getting only C by 4 and here we are getting only C plus C by 4 minus C and then the remaining last term minus 1985. Minus 1985. Right. So this is equivalent to what? Just a little calculation. Suppose. Yes. Please go. This is 125C minus C, 124C plus Y yes plus Y by 4 plus C by 4 minus 1925 is mod 7, right? Now we can simplify it more just to make it sure that it is two big numbers. Let's make it very simple. Like it will be 3 minus 2C plus Y by 4 plus C by 4 mod 7. How did we do it? It's simple because this 1985 is nothing but, let me use some other color. This 1985 was some 1988 minus 3, right? That's minus 1988 plus 3 in this way we wrote it. And this is divisible by 7. So that's why. And what is this 124C? It is written like 126C minus 2C. And it is divisible by 7. So that's why it's gone. Only 2C is remaining and 3 is remaining. So from this we get 2C because 126 is divisible by 7. So that's why it's gone. And 3 is remaining and all this remaining, these are also remaining. So let me finally say y is nothing but these are still calculations. More easy. Now in that, now previously for what this problem, what we are doing, we are using 2022 minus 1985, 2022 by 4. So big these divisions. Now it becomes very easier because for 2022, let me write it down what this goes. So this dy boils down to 3 minus 2c plus y plus c by 4 plus y by 4 mod 7. 2022 fast marks. We are finding out D2022. So 2022 C is 20, Y is 22. So D2022 is nothing but 3 minus 60. It's very easy. Sorry, 3 minus 40 plus 22. 3 minus 40, yes, 40 plus 22 plus C by 4, which is nothing but 20 by 4, which is 5. Let me write it down as 5. Box of 5 means 5. Okay. You know what? Let's use the individual notation. Blocks of 5, then it will be y by 4. That means 22 by 4. That also be something like 5.5, 2.2, right? So it is also be 5.5, of course. Yes, 22, 20, 5.5. That may also be 5. It's not 7. Nothing but 3 minus 40 plus 22 plus 10. That means what it remains? 3 minus 40 plus 22 minus 10. That will be 22 plus 23, 25. And this is nothing but minus 30 mod 7. 25 minus 30, which is nothing but minus 5. Right? Minus 5 mod 7, which is equivalent to 2 mod 7. That means it is always the 2022 1st March. It will always be 1 2 Tuesday. You can check it out by your calendar that what will be the day of 1st March 2022, which is Tuesday. Okay. So now you have noticed that only we are calculating. So far we have processed only we are calculating the 1st March of any year, like any year, the 1st March of it. So what happens if we are calculating? We'll be calculating going to any date of. Now we're going to proceed next level, which is any date of any year. So let's say 1st March. Now we're going to calculate about the December, January, February, what will happen. So for that, let me share one thing. Now, as we know that our months are different. Like our March is 30. March is 31st. April is 30. May is 31st. June is 30. July 31st. Our so it has happened. Now, if we start from March, so we know that 28. If it is 31, it is nothing but 28 plus 3. If it is 30, it is nothing but 28 plus 2. So always, if it is March, 1st of March, like say, let's write it down. If it is March, the day of March, 1st March. Let me write it properly. If we write it down, the day of 1st March, is March, 1st of March. It is always congruent modulo 1st of April plus 3, right? So 28 plus 7. Similarly, if it is 1st March, if it is April, 1st of April, the next month of April is May, and April is a 30. So it will be always congruent modulo to 1st of May, the date of 1st May plus 2. So these two actually says that basically 1st of May, nothing but 3 plus 2, 1st March plus 5. You have to add 5 days. Right. So sorry, I made a little mistake. That is nothing but this. I made a mistake. Let me erase it this way. This will be not the case. I wrote it same. I wrote it down. It is 1st of April. APR is that 1st of March plus 3. 28 plus 3. Yes. And now 1st of May will be 1st of April plus 2. That's why he said, you know, first of May is nothing but March. That means what is that if it is 1st of March, is it is Sunday, the first May would be 5th, matlab Thursday. If it is Monday, it will be Friday. That's what I was telling. If it is 0, it will be 5. So that means if the 1st of March of any month is Friday, it's Sunday, then 1st of May will be Thursday. Sorry, it will be yes, it will be Friday. Yes, sorry, it will be Friday. It increments 5. So if we make a list like this, if March, in with relationship to March, March is 0. So for April, we have to add 3 days, like we said. For May, we have to add 5 days. So this list goes like this. For June, the 1st of March is this. For June, we have to add 1 day. For July, we have to add 3 days. This is nothing but, this says nothing but 1st of July is congruent modulo 1st of March plus 3 mod 7. Obviously. Now this relationship, you know, has been explained by Christian Zeller. That's why it's called Zeller congruency. The relationship is for month. If it is month, no, it is month 1, month 2, month 3, month 4, month 5. This Zeller, Christian Zeller, has made it very easy for us. He has said that it will be nothing but 1st of the month May, it will be nothing but box of 2.6 m. M is now number of them. M is the, you know, the usual notation, the usual number that we are defining that month. 2.6 into m minus 0.2 minus 2 mod 7. Sorry. This 2.6 and 0.2, these are the equation. These numbers have been found by Christian Zeller. So that's why it's called Zeller congruency. So that means this our day. If we are talking about like this, like if you are finding out what will be the 1st of December 1990, if we are talking about, if we know the 1st of March, like if we know the 1990, the 1st of 1990, the 1st of March, this, all you have to find out is that the 1st of December, this will be congruent to this 1st of March 1990 plus only this thing, 2.6. December means if March is 1, then December is 10, right? 2.6 into 10 minus 0.2 box of this minus 2 mod 7. Let me actually show how this works. Let's see how this works. If m is 0, then let's say if m is 3, m is 2, that means April. How does it work? The 2.6 into 2 minus 0.2 box of this minus mod 2, which is nothing but, sorry, 5.2 minus 0.2 minus 2 is nothing but 5 minus 2, 3. Similarly, if we put m equals to 3 for May, it will be giving us 5. That's all. This relationship was found by Christian Zeller. So let me clean this page and write it down. That this relationship, if m is the number which represents the month of the corresponding calendar year, then the month, then the 1st of the month represented by the number m, which is will be congruent to day of the first March plus this value 2.6 into m minus 0.2 minus 2. Okay, so that's what we did. So if it is, so this thing introduces to, if we are finding of any date of any month, like if we are finding, so if it is any week, if it is finding any for any date of any month, it will be nothing but you have to find out like this, the d minus 1 plus the 2.6 m minus 0.2 minus 0 minus 2 plus dy. dy is nothing but the day of the corresponding first month of the corresponding calendar year. Now, if what we have found a relationship for dy, if we put that in, this whole relationship turns out to be this. That d minus 1 plus this part remains same, minus 0.2 box of this minus 2 plus what was this dy? This dy was nothing but 3 minus 2c, c means the sum century, the corresponding century, plus y plus c by 4 plus y by 4 mod, sorry, 2. I've been using the square bracket for a long, mod 7, right? That means the whole thing reduces into this. That week of that weekday of that corresponding year will be nothing but d plus 2.6 m minus 0.2 minus 2c plus y c by 4 y by 4 mod 7. Okay, where d is the date we are looking for, m is the month we are looking for. No, okay, if it is given as, okay, we'll talk about it. If it's the month we are looking for, c is the corresponding century, and y is the year, which is 9, which should be 0 to 90. Okay, that's we are looking. Let's give it an example. If it is 2022 22nd December, what will be the c? It is 20, y it is 22, day d is 22 as well, date, that means m is 10. But if it is 22nd of March, as 22nd of February, this is very interesting. It is 22nd of February. Then our C is 20, but if it is 22nd of February, then that means what? We know that according to this, y will be 22 minus 1, 21. Because I have said our calendar year, our 1 means March, that means first means first, and the February is 12. So this, if it is 2022 and the 22nd February, then means our year would be in this case 2021. So that's why it is 21, and the D and the remaining is the same. The D is 22 and the month will be 12 in this case. That's we are talking about. Now using this idea, we can solve some problems. Let me show you. Okay. Like if it is asked what was the day, like if it is asked what was the day of November 19th 1863. What was the day? So I have to, according to this formula, C is 18, D is 19, M is 9, and Y is 63. So this is nothing but D plus 2.6 M minus 0.2 minus 2C plus Y plus C by 4 plus Y by 4 mod 7. And if you calculate this way, we'll get, let's put it down these values. Let's say D is here 19, M is here 9, whereas C is 18 plus Y is nothing but 63, plus C is nothing but 18 by 4 plus Y is 63 by 4 mod 7. By calculating, it will be 88, which is also, we can say, 88, we know 84 is divisible by 7. So that means it will be also 4 mod 7. So this day is nothing but is congruent to 4. That means it was Thursday. Yes. So the day was Thursday. So yes, this is my presentation, and this is the, let me write it down. The final theorem is that W is D plus 2.6 M plus, sorry, minus 0.2 minus 2C plus Y plus C by 4 plus Y by 4. Here this D means the day of the constant we're looking for. Month is the day of that constant month. Is the century. I mean, not the same like 21st century, not that thing. In that case, which is 2020, it will be 20, and Y is the year. That is, which is this that year, which is that 9, which is not this 99 0 0 99. Yes, yes. So this is how we figure it out. Yes. Okay. Thank you.